All right, today we're jumping into a topic that you've probably heard a lot about, one that's really changing the game online: blockchain. Now, I know it can sound super complex, but stick with me. We're going to break down the fundamentals of this technology, and I promise it'll make sense. But first, let's start with a really simple question. Who do you actually trust with your data? I mean, really trust. Is it your bank, a social media giant, your government? This whole question of trust, it's the absolute core of why blockchain even exists. So here's our game plan. We'll start with databases, the world we all know. Then we'll look at how blockchain offers a new way to handle trust. We're going to dive into how it works, check out its different flavors, see where it's being used for real, and then take a peek into the future. Okay, first things first. Let's start with the system that basically runs our entire digital lives right now, the good old centralized database. Just think about your bank's ledger, right? All that crucial information is stored on their private central servers. Now, that's efficient, sure, but it's also got this one massive vulnerability. If that central server gets hacked, or if the data gets corrupted, or if it just goes down, the whole system is at risk. You are trusting one single company to get it right 100% of the time. Now let's flip the script and look at the alternative. Blockchain comes along and proposes this really radical shift away from that model. It introduces a completely new way to build trust in what we call a decentralized world. At its heart, a blockchain is just a database. But here's the magic trick. Instead of living in one place, it's copied and spread out across a huge network of computers. And that one simple difference is everything. It's what allows blockchain to guarantee that records are secure and true, all without needing a middleman, like a bank, to give the okay. This table just lays it out so clearly. In a traditional database, one company is in control, and the data can be changed. It's mutable. With blockchain, the network is in charge, and once data is on there, it is immutable, meaning it's basically set in stone. You can see the whole paradigm shift right here. We go from a single point of failure to a system that's spread out and way more resilient. Okay, so we've got the what. Now for the fun part, the how. How does this thing actually work? Let's follow a single transaction and see how it becomes a permanent part of the chain. This image here gives you that perfect bird's eye view of the whole process. You see, a user kicks things off, the request gets blasted out to the whole network, the network validates it, and boom, it gets added to the chain. It looks pretty straightforward from up here, so let's zoom in on those steps. All right, so it all starts when someone, let's say you, requests a transaction. That request gets sent out to all the computers. We call them nodes in the network. And this next part is absolutely crucial. All of those nodes have to agree that your transaction is legit. Once they reach that agreement, or consensus, your transaction gets bundled up with a bunch of others into a new block, which is then cryptographically chained to the previous one. And that's it. It's a permanent record. And that whole agreement process, that has a name. It's called a consensus mechanism. You can think of it as the engine of the blockchain. It's the rule book that allows a whole network of strangers who have no reason to trust each other to all agree on a single version of the truth. No boss, no referee, just code. Now, the two big ones you'll hear about are proof of work and proof of stake. Proof of work, which is what Bitcoin uses, has so-called miners using insane amounts of computing power to solve a math puzzle. The first one to solve it gets to add the next block. It's super secure, but, and this is a big but, it uses a shocking amount of energy. That's a huge reason why a lot of newer systems are shifting to proof of stake. Here, validators lock up their own crypto as collateral. The network then chooses one to create the block, and if they try anything shady, they lose their staked money. At the end of the day, both systems are designed to make cheating incredibly difficult and expensive. They just go about it in very different ways. Okay, here's something you've got to understand. Blockchain is not a one-size-fits-all thing. It actually comes in a few different flavors, and each one is designed for a very different purpose. This table lays it all out pretty nicely. You can have a blockchain that's totally open to everyone, one that's invite-only, or one that's run by a select group. And that choice has a huge impact on things like how decentralized it is, and maybe more importantly, how fast it is. Usually, the more open and decentralized you get, the slower the transactions are. So when you hear blockchain, you're probably thinking of a public one. These are completely open networks like Bitcoin or Ethereum, where literally anyone can participate. But then you have a private blockchain, which is controlled by a single organization. You need an invitation to get in. This is perfect for a company that wants to use the tech for something like tracking its supply chain, but, doesn't want to broadcast all that business data to the entire world. Then there's the consortium blockchain, which is kind of a middle ground. It's run by a group of organizations, not just one. Think about a bunch of banks getting together to create a shared, secure system for payments. And last, you have the hybrid blockchain, which, you guessed it, mixes private and public. A hospital, for example, might keep patient records on a private chain for privacy, but then use a public chain to prove that those records haven't been tampered with. All right, enough with the theory. Let's talk about where this technology is actually making a difference in the real world, beyond all the crypto hype. No surprise, finance is the big player here, taking up almost half the pie. But what's really fascinating is how fast other areas are catching on. Healthcare is actually set to be the fastest growing sector, and we're seeing some really powerful uses in retail, media, and even education. And we're not talking about hypotheticals here. This is happening right now. In finance, it's making cross-border payments way faster. In healthcare, it's letting hospitals share patient records securely. High-end brands like Gucci are using it to track their products and prove they're not fake. And the EU is even building digital ID systems for its citizens on the blockchain. This quote from a healthcare expert, Victoria Yaskovich, really nails it. The true power here isn't just about security or data, it's about collaboration. By creating one shared source of truth, it allows groups that normally don't work together, like hospitals and insurance companies, to finally get on the same page in a totally new and transparent way. So, where is all this heading? Well, the ultimate goal for blockchain isn't to be the next big buzzword. It's to become so fundamental that it just disappears into the background, becoming the new trust layer for everything we do online. And this quote really sums it up perfectly. Think about it. You don't really think about the technical protocols that make the internet work, right? You just use it. That's the future of blockchain. We'll all be using systems built on it because they're more secure and reliable without even knowing or caring that blockchain is under the hood. It just becomes invisible. And there are three huge trends pushing us toward that future. First is the tokenization of real-world assets. I mean, imagine turning a piece of a building or a work of art into a digital token you can trade instantly. Second is the link up with AI, where blockchain can provide a perfect, unchangeable audit trail for how an AI made its decisions. And third is interoperability, getting all these different blockchains to finally talk to each other, creating a true internet of value. So I'll leave you with this thought. At the end of the day, blockchain isn't just about digital money or fancy databases. It's about something much more fundamental, programming trust directly into our code. So the real question is, when trust is just a given, built into the very foundation of our digital world, what new things become possible?